Okay, cool. So let's get into this next breakout. There you are. And I'll put 4 minutes on the clock. Oh, I'm sorry. Gosh, I gotta actually put that hold string in there. Post your solutions after you get them working, by the way. All right. Cool. So for this one, I just kind of scaffolded this out. Quick reminder, pay attention to your workflow. write a test, build up your function stub with a return, whatever you're going to accumulate. Just assume every problem is an accumulator until you're proven otherwise. So in this case, obviously I'm assuming this is an accumulator because we're talking about accumulators, but I would anyways. So I'm starting a accumulator. It's a string because I know I want to return a string. So usually my accumulator is of the type that I want to return because it's kind of the point. And then I have my return, so I can print out and monitor what I'm returning. And every time I run the code, it's going to call the function here. Whatever it's returning is going to get printed out because it's inside of a print. Okay, cool. So I'll just say for character in, oops, I got to take in an input. So let's just call this text. So for character in text, if character in, we'll say not in vowels. So this will be A, E, I, O, U, and we'll just count Y. And you know what? I think I need to. I'll do capitals as well. Actually, let's do that. So I'll just do lower dot lower here on C. So if C dot lower is not an A, E, I, O, U, Y, we'll say S, then we'll accumulate plus equals C. And this should give me the string back without any vowels. Cool. And it looks like this is basically the same thing, except they have this, they're checking for membership rather than for absence, but same deal. And then they have an else, but it's the same logic essentially. All right, we got another one. Oops. Let's do this. Okay. Oops. There's that little test for you. And we've got 4 minutes on the clock. Okay. That's good there. So I'll show a solution for this. Go ahead and just paste in whatever you've got. That's fine. There we go. Oh, cool. Good, good. We've got a few answers here. Great. Again, I have my test. Test has some data, some list. I'll do this. Some list equals the list. And then it has some expectation about what we should get, which is a string of 24. So we're just accumulating the strings of the versions of the even numbers. So I have my accumulator target. I have my return. So now it's just for num in list if num mod 2 equals 0, then it's even. Then I'll stir plus equals num. So if I try to do this, obviously we're going to get an error. We've got a num. We're trying to add to a string, and it doesn't know how to do that. Unbound local variable stir reference before assignment. Oops. That's the wrong error. I was like, wait, what? That's not the right error. S. So I can't call something stir anyways. I don't know why I did that. So type error can only concatenate stir, not int to stir. So it doesn't know how to add a string and an int together, which is fair. So we have to convert the num to a stir first. 24. There we go. And just to prove that it is indeed a string and not the number 24, we can say type. Let's see what we get. So that's a string. Good. All right. Okay. Okay. Sorry. Second here. Audio. Okay. List accumulators. So let's see. List accumulator, we just start an empty list, run through a loop, append to the list. Usually, overwhelmingly, append is the operation that you're going to use to a list. You're just collecting elements in whatever order. So that's, I feel like that idea is fairly well solidified at this point. Of course, I may be wrong, and I will repaste this. Now, go ahead and post your solutions when they're done. All right. Go ahead and get your answers in. I'll do a solution for this one really quick. So I just have my test data and just the problem statement. So I figured I'll just show building the sort of scaffolding and the testing. So print function name, test data, def function name, stir1 sounds like text to me. We're going to return a list. Oops. So write a function called this with two parameters, a list of letters and a string. Okay. Let's call this let list for letters list. The function should return a new list. Let's call it list. Filled with the words from the string that start with the letters from the list of letters. Okay, cool. So I'll say for word in text dot split. So for each word in text dot split, I'm getting each word because I'm doing dot split, and I know that's going to split the words. You know, I think no, I don't want to lower there. I'll lower in here. So I'll say if word sub 0, which is the first letter in each word, dot lower. I'll just standardize the casing here. So if each word dot lower, the first letter in each word dot lower in let list. So if it's a member of the letters list, then we'll list dot append word and return. Cool. Oh, right. So let's say I totally just forgot to give it the list. Let's say B C W. Oh, what am I doing? Okay, we'll do that. Beautiful, beautiful, could be, would be. Cool. All right, so that's what we get for that particular input. Yeah, I'll post the solution. The solution's also in the slides here. There's another one. Let's see if they did anything. No, this is like exactly the same. It's just a little bit of a different naming convention. I will post my solution though. Okay, we're going to skip this next list breakout and jump into dictionary accumulators. I want to spend a little more time on dictionary accumulators because I feel like list accumulators, you know, basically, if you know how to use append, you're kind of good. Maybe there's a little more to it than that, but that'll definitely get you through a lot of problems. And you know, when that won't do, you'll already have enough experience, like kind of working with lists, that you'll be able to manipulate them. But dictionaries have a little bit of an extra lift. So I just recently went over this very topic yesterday, actually on stream. I went over the dictionary accumulators section in Learn. So dictionary accumulators, I break these into a few different categories. let's call them pure dictionary accumulator. So a pure dictionary accumulator is where we start with just an empty dictionary, and we are going to accumulate full key value pairs into the dictionary. The second kind of dictionary accumulator I think about, I kind of call it categorical. I think I spelled that wrong, but whatever. You know what I mean. So categorical dictionary accumulation is where we already kind of know our categories, essentially. Just to be clear here, these are terms that I use, that I kind of use to describe these. So I don't necessarily want you to like remember like which one is which, but like just make a distinction between, do I know my keys or not, basically. Do I know what the keys in the dictionary are or not? So categorical is where you know what your key value pairs are. So if we have like A, B, oops, C, I don't know. Oops, I made a mess here. Okay, so in this case, we know what our key value pairs are. These are just arbitrary, this could be anything, but we could do something, we could do a variation on this problem, words that start with, and we could do, let's just make this a dictionary accumulator, and instead of taking in a list, we'll just do a dictionary like this, and we already know what our key value pairs are, and let's say our values are going to be a list of each of all the words that start with each of these, right? So this is going to be words that start with A, B, C, dict. Okay. So we'll take in string 1, and in this case, I'll check if the first letter of the word dot lower in, instead of letters list, I'll say d dot value or keys. I'll check if it's a member of the keys of the dictionary. And if it is, I'm not going to append to something called list, but I am going to append to d sub word sub 0. And I could simplify this. Let's do this will actually be like this. First letter equals this. There we go. So d sub first letter dot append word, and then we'll return d. First letter is not defined. Did I have a... Oh. I misspelled it. Okay, there we go. Yeah, okay. So in this case, when I have a categorical, and I'll get to the pure form here in a second here, but when I have a categorical accumulation, I'm thinking about it in terms of not really as a dictionary accumulator, but this is really a list accumulator, right? It just happens that the lists I'm accumulating into live inside of a dictionary. So it's a dictionary list accumulator. So this, when you have a categorical style, when you already know your keys ahead of time, you know that you're actually accumulating onto the values of those keys. The values in this case of every key is a list. So I'm going to be doing a list accumulation onto lists that are values in a dictionary, right? So it's kind of a hybrid between a list and a dictionary accumulator. So notice on my output, I don't have any key value pairs in here that I didn't have before, right? So I might, let's do another variation on this. Let's do like, let's do a word frequency. That might be actually what we're doing here. Yeah. Let's do a word frequency dictionary though. I'll just do an example of this. Word. So word frequency dictionary. In this case, so this will be a pure form. Like this. Okay. So in this case, we don't know the key value pairs ahead of time. So the keys that I want to produce from this are going to be the words, and then the values are going to be the counts. So an integer representing the number of occurrences. Okay, so again, I'll say if word not in d.keys, I'm going to say word d sub word, and this is going to create the key value pair. So d sub word equals so it'll be the count of, we'll say list equals text dot split. Let's just call it, let's be clear, this is, oops, oh no. This is word list. So for word in word list, we'll say word list dot count word. Okay, so I made a word list. I made my accumulator for word in the word list. If the word is not a key in the dictionary, then add it and set its value equal to the count of word from word list. So however many times word occurs in word list. And then once it's all done, return D. Okay, so this is what I would call a pure form dictionary accumulator, because we are truly accumulating onto the dictionary in like a dictionary-ish way by adding in new key value pairs that weren't there before. Okay. So if we look at this, actually, why don't I do this? For KV in dot items cool. So this shows us each word and how many times it occurs in the input list, right? So this is word frequency. Okay, so these are the two sort of major distinct forms. We have the categorical, which just means we know, basically we know we have predefined key value pairs. What that almost always means is that the form that the accumulation is going to take is the form of the values, right? So I think about this as a list accumulation within a dictionary. And this could be mixed form, right? This could be, we might be accumulating into something that keeps track of a list of one aspect of the thing, and a count as an integer of another aspect of a thing, and a string, you know, right? So we may have multiple styles of accumulators to deal with in a categorical style. And that can be true in a pure style, but it's not as often. So in a pure style accumulator, all we're doing is accumulating key value pairs. And the action of accumulation occurs like this. D sub word equals some value. So D sub some key name equals some value, right? And in this case, we can determine that in one line. So what happens quite often is some hybrid form of the two, where we accumulate new key value pairs, and then we accumulate onto those keys. And I'll show a version of this. It's not going to be, it might sound scary. Trust me, it's not that bad. So hybrid, and I would say, I don't know, in my experience, I think the hybrid form is probably safe to say the most common. So I'll start with something similar here, but instead of doing word frequency, let's do word indices dict, right? So rather than returning a dictionary of word colon int of count, right? So rather than returning a dictionary of string int, I'm going to be returning a dictionary of string list ints of indices, IDXs. Okay, so instead of word int, instead of string int, it's string list of int. So that's the new paradigm here. Okay, so actually let me get my regular I'll just open up my notes document here, and I'll grab my sample text, because this actually is kind of a little bit better to deal with for this. Okay. So I got some sample text, and I'm going to test my word indices dictionary. We'll start with the same thing, empty dictionary. We're going to accumulate key value pairs, but instead of doing the count here, I'm going to initialize an empty list. And then once I'm sure d sub word exists with at least an empty list in it, I'm going to say d sub word dot append index. And in order to get the index, I'm going to need to enumerate. There we go. Whoops. Str1 is not defined. Oh. Okay, well. There we go. That should do it. All right. So now here's our output. So whose occurs at index 0, woods occurs at these indices, I occurs at these indices, etc. Right? So why is this a different form? So let's see what's happening here. We'll do a quick recap. So our categorical is where we know the key value pairs, and we kind of treat the accumulator style more like the value type rather than a dictionary type. But obviously, we have to interact with the dictionary and accumulate into the appropriate location, right? The pure style is just where we're accumulating key value pairs. That's happening here on line 144. D sub key name equals value. whatever the value is. Happens in a single action. So this is something similar where we're accumulating key value pairs. We're accumulating key value pairs, but when I accumulate the key value pair, I just initialize an empty list and then immediately accumulate into that list. So I'm accumulating into a dictionary and I'm accumulating into a list in the dictionary, right? So this is both pure, where we're doing key value pairs, and sort of categorical, and it's kind of we're kind of flexing that term a little bit, but we're also appending in and accumulating onto something, a category that we've already found via finding the key value pair, right? Cool. I'm assuming everybody's doing good with this. I know I'm moving a bit quickly. Well, I say that, but like I said, I'm actually moving a bit slower this time than I have been. But feel free to stop me and ask if I'm just like going off the rails. If it's not making sense, tell me like, hey, it's not making sense. Okay. Feel free to put in a question if you've got one. So let's see. Let's just go through this code along. Okay. Okay, here it is. So write a function that will, for any given string, return a dictionary that gives us the number of vowels, number of vowels, number of non-vowels, and number of non-alpha characters. So this right away, I look at this, and these are predefined categories, right? So this is a code along. Please pull up your REPLs and kind of code along with me. If you get an error, let me know, and I'll do my best to help you out. So what should this function be called? I'm thinking, let's call it def string info, string data dict, and this will take in text, and return D. Let's initialize our dictionary, and we're going to have predefined categories here. So I'm going to do my little formatty thing. We're going to have vowels, and this is just going to be a count of the vowels. Consonants. And non-alpha characters. So these are going to be numbers and special characters. So this is very much like the categorical version that we did. I mean, this is just a regular old categorical dictionary where we know our categories ahead of time, and we're going to accumulate on integers, right? These are going to be integer accumulations. We just need to make sure that we do them in the right place. Okay. So first of all, we need to be able to detect these. This is information about each character, about characters in the text. So we probably need to look at each character. So we can look at each character by saying for character in text. And from here, we can determine if it's a vowel or a non-alpha or a consonant. So, gosh, I gotta look this up. every time. So I'm going to go look up my string methods. IPython 3. And we'll do dir of string. And I'm going to go to my is's up here. The is, alnum, is alpha. So there's a bunch of like is something about string. I know that there's like all these is's, and all the ones that start with is, return true or false as to whether the string is alpha or is numeric or whatever. So here's a nice one. So is alpha. So strings have a method called isAlpha. And I couldn't remember, like, I know there's like an alnum, and I couldn't remember if it was isAlpha or whatever. So I know I could use this one to tell me if it's not an alpha, right? So if I can tell if it is an alpha, I can just invert that. So I can say if not c dot is alpha, then we know d sub non-alpha, d sub non-alpha should be plus equal to 1. If it's not this, then we know it definitely is an alpha character, which means we can see if it's a vowel. So if, elif c in, we'll do c dot lower in a, e, I, o, u. Let's just do y, because why not? Why not? Okay. So if it's in that, if C is a member of that substring, then we know it's a vowel. So we'll do vowels plus equals 1. And if it's not alpha, then it's an alpha. Meaning if it is an alpha character and it's not a vowel, then it's a consonant. So else d sub consonants plus equals 1. Okay, so let's do, I'll just grab my test string here really quick. And we'll string data. I didn't start with my test, did I? I mean, I definitely didn't. Broke my own rule. Okay, there we go. So 173 vowels, 249 consonants, and 125 non-alphas. So if I do dot values, and I think I can do, so I'm going to just check this real quick. I think I can do len. Can I do len? There are 3 values. Dang. Can I do sum? Yeah, there we go. So the sum of the values should be equal to, or at least approximately equal to, the len of the text. So len text. I'll just do this. Oops. Yeah, perfectly equal. Okay, good. That means we got every character. We counted for every character, right? So since we're counting vowels, consonants, and non-alphas separately, if we sum those together, that should be equal to the total number of characters in text, like that. Can the test be pasted in? Yeah, I'll paste in the test. I'll just paste in the whole thing. There you go. Okay, cool. Let's see what they did. I might have gone totally off the rails, which is whatever. Chars.lower. Oh, hey. Yeah, I think this is going to conclude with basically the same code that I had. Yeah, it looks like they're checking vowels and is alpha in the opposite order, but I don't know, my way's better. Okay. Let's see, does this have... Oh. Ah. Somehow the final solution got deleted out of there. That's okay. Wanted to showcase just a small variation on this, because I had mentioned like we could have multiple different types in here, right? Like let's say vowel words could be a list of words that start with a vowel. So if, and we can just roll that into here, right? So if c.lower is, oh dang, because I don't have access to words, I would have to do a whole nother loop there. Let's do something easier. Vowel indices. And we'll just collect the indices of each vowel. Enumerate IDX, and we'll say vowel indices. So notice, I know some people will say, oh, I didn't know you could append to a dictionary. To be clear, you cannot append to a dictionary, and I should have mentioned this before. This is not appending to a dictionary. This is appending to a list that is located inside of a dictionary. So I just wanted to show this example because, you know, we don't necessarily, when we have a categorical dictionary like this, it's not uncommon that we might have a mix of types to accumulate onto, right? So, you know, you just account for that in your thinking. Like, I'm accumulating onto integers in certain situations, I'm accumulating onto a list in certain other situations. Of course, if we really wanted to be sadistic, we could have other dictionaries to accumulate onto nested inside of our dictionaries, but there's some point at which you have to just look at your data structure and say, do I really want to do this? How much self-respect do I feel like I deserve today? I don't know. Something like that. Okay. Cool. That puts us right at time, actually. So we're not going to get through this second dictionary accumulator. I don't think I'll go through it next time unless y'all request it or want me to. I'll leave it to you to go through this. Just treat it as like kind of a code along, step by step. You know, read each prompt, see if you can do it on your own, then go to the next one. You know, make variations, be creative. Feel free to go off the rails, and then kind of let this guide you through it, through the next code along. Next time we'll be going through the function practices, and it'll just be basically breakout after breakout. So yeah, we'll wrap up there. I release you off into the world. You'll have a good rest of your day. If you want to go, feel free to hang out and ask questions if you've got them. Let me stop the recording and we'll go from there.